Hello, welcome to Unit 7, Lesson 4. In this lesson, we're going to be talking about solving quadratics. I'm Professor Blackman. So in this lesson, we're going to be talking about the discriminant. So the discriminant is the b squared minus 4ac. When you're looking at the quadratic formula, which is the opposite of b plus or minus b squared minus 4ac all over 2a. So when you're looking at this, if it equals 0, you have one solution for the discriminant. If it is greater than 0, you will have two real solutions. If it is less than 0, you'll have two complex solutions. All right. And then there's also if it equals a perfect square. This isn't written in most books, but if it equals a perfect square, then you'll have two rational solutions, which just means it's going to be either a nice fraction or a nice integer. So that this is what we're going to be focusing on today is the discriminant and then the quadratic formula. All right, let's go ahead and get started. So we're going to calculate the discriminant, and as you see here, one real solution, two real, one real, or two complex, as I mentioned on the previous page. So using ax squared plus bx plus c equals 0, so all of this, we can identify a here as 1, b here is -8, and c here is -20. So when we plug into our b squared minus 4ac, we get -8 squared minus 4 times a times c, which will give us 64. Negative negative is positive, plus 80, which is 144. So this will be two real solutions. And since 144 is a perfect square, we can also say that it will be a rational solution. All right, so here A is 3, B is 1, and C is -2. The coefficient, and constant. So when we plug in b squared minus 4ac, we get 1 squared minus 4 times 3 times -2. So 1 squared is 1, negative negative is positive, 4 and 3 is 12, and times 2 is 24. So this is 25, which is two real solutions. And since 25 is a perfect square, we can also say that it is rational. The two solutions will be rational. All right, here we can identify A as 5. As you notice, the bx is not there because it's 0x, so we say B is 0, and C is 10. So b squared minus 4ac. That's 0 squared minus 4 times 5 times 10. That is 0 minus 4 and 5 is 20, times 10 is 200. So this is -200. So that is less than 0, so this would be two complex solutions. All right, over here we can identify A as 1, B is also missing again, so it's 0, and C is 16. So that's 0 squared minus 4 times 1 times 16. So that's 0 minus 4 times 16 is 64. So that's a -64, which again gives us two complex solutions. All right, let's look at some more examples. Okay, so now we're going to look at the quadratic formula, which is right here. It is x equals the opposite of b plus or minus b squared minus 4ac. So we do the same thing that we started with discriminants, where we identify our a, identify our b, and identify our c. And so when we're going to plug, all we have to do now is just plug in and simplify. There's your discriminant right there, and all over 2 times a. So I like to do my discriminant on the side, just because that's the most complicated part of the formula, and that way I have to write it less. Minus 4 times a times c. So that is 64 plus 80, which is 144. So then this is x equals the opposite of b, so opposite of negative 8 would be 8, plus or minus 144 over 2 times a. So then this equals 8 plus or minus 12 divided by 2. So now we need to split this into two problems. So it needs to be x equals 8 plus 12 divided by 2, and x equals 8 minus 12 divided by 2. So that is x equals 20 over 2, so x equals 10. This is x equals negative 4 over 2, so x equals negative 2. And these are solutions, so you can plug them in and do 10 squared, which is 100. 8 times 10 is 80. 100 minus 80 minus 20 gives you 0. Plug in negative 2, you get 4 plus 16, which is 20. 20 minus 20 gives you 0. So they are solutions, so you can always check by plugging in. Let's identify our a as 3, our b as 1, and our c as negative 2. So when we plug in, and again, I always rewrite my formula, so that way it helps me remember where to plug in directly, all over 2a. I like to do my discriminant on the side. So that's 1 squared minus 4 times 3 times negative 2. So that's 1 plus 24, which gives me 25. So now I have x equals the opposite of 1 plus or minus 25 over 2 times 3. So that's x equals negative 1 plus or minus 5 over 6. So now when you split into 2, so that'd be x equals negative 1 plus 5 over 6, and x equals negative 1 minus 5 over 6. So negative 1 plus 5 would be 4, so 4 over 6 becomes 2/3. And then x equals negative 1 and negative 5 give me negative 6 over 6, so that gives me negative 1. And so those are our two solutions. And again, you can always plug them in and check, which I've shown in previous videos. Let's look at some more examples. All right, so here we can identify a as 5, b as 0, and c as 10. So x equals the opposite of b plus or minus b squared minus 4ac all over 2 times a. b squared minus 4ac is our discriminant. So that would be 0 squared minus 4 times 5 times 10, which is 0 minus 200, or negative 200. Okay, so then we have x equals 0 plus or minus the negative 200 as the discriminant, and 2 times 5. So that's x equals plus or minus square root of negative 200. That is square root of negative 1 times 100 times 2. So that would be 10I root 2. So we're going to put 10I root 2 over 10. So then x equals plus or minus 10 divided by 10 is 1, so then we have I root 2. Now you can leave it like that, or if you were asked to put it in complex numbers, then you would have to write as x equals 0 plus or minus square root of 2I, just depending on what form you need to put in, but either one should be accepted. All right, so let's identify what we have here. Here we have A equals 1, B equals 0, and C equals 16. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And so we have our discriminant as b squared minus 4ac, which is 0 squared minus 4 times 1 times 16. That's 0 minus 64, which is a negative 64. And then we have x equals 0 plus or minus the square root of negative 64 divided by 2 times 1. So let's look at square root of negative 64. Well, that is just negative 1 times 64, so that becomes 8i. So this is x equals plus or minus 8i over 2. So that is x equals plus or minus 8 divided by 2 is 4, 4i. And that would be our solution. All right, let's look at another example. So let's start by identifying A as 1. B here is negative 2. But if you see, this doesn't equal 0. So we need to make sure we put this as x squared minus 2x minus 15 equals 0. If you don't make that change, you're going to write C as 15. But you need to make sure it equals 0 so we can write C as negative 15. I'll go ahead and take this one over here as well and rewrite it as 3m minus 2 equals 0. And we can identify A as 5, B as 3, and C as negative 2. So now that we have all that, let's go ahead and plug in our formula, quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. All right, I'm going to calculate that discriminant first, the b squared minus 4ac, and that would be negative 2 squared minus 4 times 1 times negative 15. All right, negative 2 squared is 4. Negative and negative is positive. 4 times 15 is 60, and this gives me 64. So that's positive, so this will give me 2 rational, real solutions. All right, so then we have x equals the opposite of b, which would be 2, a negative negative 2, plus or minus square root of 64, all over 2 times 1. So that's x equals 2 plus or minus 8 over 2. Split that into 2 problems, 2 minus 8 over 2, and x equals 2 plus 8 over 2. So 2 minus 8 is negative 6 over 2, which gives us a negative 3. And then this is x equals 2 plus 8 is 10 over 2, which x equals 5. So we get x equals negative 3 and 5. We can plug those in, check. 9 minus plus 6 gives us 15. And plug in 5, you get 25 minus 10, which gives you 15. Both of those are good. Remember, with any equation that you are solving, we can always check our solutions. All right, so then we have x equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, so I'm going to calculate my discriminant on the side. So let's plug in to find the discriminant, and we get 3 squared minus 4 times 5 times negative 2. All right, so 3 squared is 9. Negative and negative is positive. 4 times 5 is 20, times 2 is 40, and 9 plus 40 is 49, which will give us 2 real, rational solutions. Plug in, and we get the opposite of 3, plus or minus square root of 49 all over 2 times 5. That's negative 3 plus or minus 7 over 10, which will split into 2, which will be negative 3 minus 7 over 10, and x equals negative 3 plus 7 over 10. That gives us negative 10 over 10, which simplifies to negative 1. And this one over here gives 7 minus 3 is 4. 4 over 10 gives us 2/5. All right, when we put those together, that's negative 1 and 2/5. All right, let's look at some more examples. All right, so this one's already in standard form, so we can identify A as 1, B as 1, and C as 2. All right, so x equals negative b plus or minus square root b squared minus 4ac. And again, I like writing it every time so it helps stick to my long-term memory. And then we plug into the discriminant, and we get 1 squared minus 4 times 1 times 2. So that's 1 minus 8, which will give us a negative 7. So this is going to give us 2 complex solutions because it's less than 0. All right, so we get x equals the opposite of b plus or minus the square root of negative 7 all over 2 times 1. So that's x equals negative 1 plus or minus I root 7 all over 2. Now, if you don't need to write in a plus bi form, you can leave like that. But if you need to put in a plus bi form, it would be negative 1 half plus or minus square root of 7 over 2i. And you could write that as 2 separate ones or just one big one. All right, let's go ahead and look at our next example. And so here we need to rewrite it as 3x squared minus 5x when we move it to the other side plus 4 equals 0. So we get a equals 3, b equals negative 5, and c equals 4. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. Put my discriminant on the side. Negative 5 is my b, 3 is my a, and c is 4. So that's 25 minus 4 times 3 is 12, times 4 is 48, and that gives me a negative 23, which would give me 2 complex solutions. So I know somewhere in my answer there will be an I. So x equals the opposite of b, which is a positive 5, plus or minus negative square root 23 all over 2 times 3. So then we get x equals 5 plus or minus I root 23, which is a prime number, so I'm not going to simplify, all over 6, which then, of course, to put in complex a plus bi would be 5/6 plus or minus square root of 23 over 6i. All right, let's look at another example. Okay, so we can identify a as 1, b as -8, and c as 5. So when we plug in, we get x equals -b plus or minus b squared minus 4ac, which is our quadratic formula. Plug in to get the discriminant. So that's -8 squared minus 4 times 1 times 5. So that's 64 minus 20, which is 44. So we will get 2 real solutions. Okay, so that will give us x equals the opposite of b, which is 8, plus or minus square root of 44, all over 2 times 1. So that's x equals 8 plus or minus square root of 44 is, do it on the side, that is 4 times 11, so that's 2 root 11, all over 2. And if you notice, we're dividing by 2, so then we can divide top and bottom by 2 because they are both multiples of 2 as well. So that gives us 4 plus or minus root 11. All right, let's work our last example. First, we notice it's not set equal to 0, so we can quickly do that. And then we can identify a as 3, b as 1, and c as -5. So we can write out the quadratic formula. All over 2a. Do our work for the discriminant on the side. And so that will give us 1 squared minus 4 times 3 times -5. And so that'd be 1 plus 12 and 5 give you 60. Add those together, you get 61. So the 61 lets us know we'll have 2 real solutions. And so we have x equals the opposite of b, so -1 plus or minus square root of 61 all over 2 times 3. So that's x equals -1 plus or minus the square root of 61 all over 6. And that's it. This does not simplify any further. Nothing comes out of the square root of 61. That is your final answer. All right, that's all I have for you today. Happy studying.